The ratio test is something students usually like because it's a lot more clear. There's less conditions you have to really check to make sure they can apply the test to determine whether it's convergent. It's nice and simple. You evaluate the limit as n goes to infinity for the ratio of the next term divided by the current term. So to evaluate that limit, I'm evaluating the absolute value of n plus 1 to the 12th power over 6n plus 1 divided by a sub n, divided by n to the 12th power over 6n. And so I'm going to just drop limit for just a second because it's hard to write. We'll flip and multiply the second fraction. And probably the most immediate thing that we can see here is you have 6n plus 1 in the denominator and 6 to the nth in the numerator. So still limit. And so the 6 to the power of n, 6 to the power of n plus 1, those can cancel out. So that we just have a 6 in the denominator. Because it's like you're doing n plus 1 subtracted by the power of n. So it's just like when you had x to the 4th over x to the 6th, that would be 1 over x to the second power, right? So that's what we have in the denominator, and in the numerator, it's close, but we can't cancel anything out because the bases aren't the same. But remember, we're evaluating the limit as n goes to infinity. So the highest power in the numerator is going to be n to the 12th if you were to expand this by multiplying a bunch of binomials together. The highest power in the denominator is n to the 12th. So those powers are going to level out into a horizontal asymptote, and it's going to be a ratio of the leading coefficients. So if you were to multiply all these parentheses out, you'd have 1 n to the 12th power. So the 1 over 6 is going to be this limit. Okay, so that's the first part. To evaluate the limit, it's 1/6. So since the limit, I think actually our text uses capital L, but since the limit is less than 1, this is convergent by the ratio test.